Hello! In this presentation, I'll be analysing the original data of private sector building approvals in Australia using multiple linear regression in Excel. The aim is to identify time trends and seasonal effects and to forecast the values from July for the out-of-sample period. Before I begin this presentation, I would like to acknowledge that the information from this case study has been attributed from the Australian Bureau of Statistics, utilising Table 6, number of dwellings approved. For exercise 1 and 2, seasonally adjusted data and original data were asked respectively. This report covers 107 monthly observations from July 2015 to June 2024, using number of dwellings approved monthly as the primary measurement value. So now I'll demonstrate how I ran the multiple regression model in Excel to forecast private sector building approvals. First, I prepared my data set with a time column here to capture trend and create 12 dummy variables representing each month from January to November, with December being the base month. These dummy variables allow the model to account for seasonal variation. Next, I opened the data analysis toolpack and selected the regression function, and I press OK. I set the number of building approvals as the Y range and included time and the month of dummy variables from C1 to N109 cells as the X range. I tick labels. I set the output range to cell P2 because it's an empty cell, and I ticked residuals, standardized residuals and the residual plots, and then I press OK. So here is our output. Our R-square is set at 0.53 here, which indicates it's a moderate fit. The significant F value is extremely small, meaning that the overall model is statistically significant. This is the F value here, 8.901. From the coefficients, I then derive a forecasting equation which combines the trend and seasonal effects. The equation is the intercept coefficient plus time coefficient x, so that is 18,345.94 times plus minus 53.45x. This equation was later used to generate the within sample and out of sample forecasts. Now we're going to be analysing the output. This is the output graph here, and as you can see here, the chart compares actual private sector building approvals from 2015 to 2024 with my model's forecast, the out of sample forecast from June 2024 to July 2025. So the orange line is the out of sample, the blue line is the actual forecast. We can see that approvals fluctuate between roughly 10 to 25,000, but overall the trend is gradually declining over time. There's a clear seasonal pattern. Activity tends to peak around May and November, while the lowest levels occur in January, which aligns with typical construction cycles after the holiday period. My model's R-square value is around 0.53, meaning that just over half of the variation in approvals is explained by time and seasonality. Although this isn't a perfect fit, it's fairly strong for economic time series data, which are often volatile. Overall, the forecast continues the gentle downward trend seen in previous years, suggesting stable but slightly weaker private sector building activity through 2024 and 2025. Now I'll be articulating some of the issues present. So these residual plots show the model's errors for each monthly dummy variable. So we have residual plots from July and November as comparisons. These residuals are mostly scattered around 0, which means the model fits the trend and seasonal components really well. There's no strong pattern or curvature and no large outliers, indicating that there's no systemic bias in the model. The slight clustering of points around 0 and 1 is expected because of how dummy variables work. And overall, the residual plots confirm that the model performs reasonably well with only minor autocorrelation, which is common in monthly data. So finally, I'll be critiquing and positioning my data set. When critically evaluating this regression model, it performs reasonably well for short-term forecasting, effectively capturing the time trend and seasonal variation. The R-squared value of around 0.53 shows a moderate fit, strong enough to provide useful insights but not perfect accuracy. While the residuals are mostly random and indicate a good overall fit, some mild autocorrelation is present, which is expected in monthly data. A few dummy variables were not statistically significant, suggesting that seasonal effects differ slightly across months. The model's simplicity and transparency makes it practical for short-term business forecasting and decision-making, especially when regular updates are possible. However, because it assumes a linear trend, it may not capture structural or policy-driven shifts in the construction sector. Overall, I would position this model as reliable for short-term forecasts and trend identification, but less effective for long-term or high volatility predictions. Thank you for listening to my presentations, and have a good night.